Back in time.
Okay. Cool. Some of you might have seen these before, you may not have. So, okay. I want to graph this thing, 1 over x. Do we know what that looks like off by half already? No, haven't done it before. Okay. Cool. So, I don't know what this graph looks like. What should I do to figure out what it looks like? Say again. Right, sub something in, right? What would you like to sub in?
1.
1, okay. Yeah, alright, we'll do that. Cool, we sub in 1. What do we get? 1. So, a point 1. I'm making these halves, so that's half 1, 1 and a half 2. So 1, 1 is going to be
1, 1.
there. Cool, okay, great. What do you want to do now? 2, okay, sub in 2, what do you get?
Half.
Half, alright, so 2 goes to a half. Great, alright, is that straight? I'm not so happy with that one. Try that again, there we go. Cool, alright, what else we got?
Negatives.
Chuck in some negatives, okay, what number are you avoiding?
0.
0, why?
Because it's undefined.
Right, undefined. Alright, if I'm dividing by 0, I get undefined. Where's undefined?
No, it's undefined.
Right, it's undefined.
Somehow.
Okay, so we go into negatives. Chuck in negative 1, what do you get?
1.
Right, 1 divided by negative 1, negative 1. Cool. What do you want else to chuck in?
Negative 2.
Negative 2, and you get?
Other side.
Cool. Is it obvious at all where this line's going?
Yes.
Is it? Okay, where's it going?
Never mind. I thought it was going to be like wave.
Okay, it could be going some sort of wave. That's one possible way of doing this.
Could be
Alright.
parallel.
Could be parallel. When you say parallel, as in 2 parallel lines? Okay, maybe. Alright. Is it possible to draw a line through this multiple different ways?
Yeah.
Yes, so are we convinced that we know which is the correct way? Probably not.
Oh, yo. It's just like that and like that.
Okay. So, let's sub in some other things just to verify whether I'm right or not. Let's sub in a half. 1 over a half? 2, right? 1 over a half goes to 2. Cool. 1 over negative a half.
Asymptotes.
Right, we'll get into it. 1 over negative a half. Next 2.
Asymptotes.
Cool. Alright. 1 over 3 halves.
3. 1
over 3 halves.
Oh, halves. Would be 2.5.
2, not 2.5, no.
1.
2/3, right? Because this is the same as 1 divided by 3 on 2, which is the same as 1 multiplied 2/3. 1 multiplied 2/3 is 2/3. So it must be about there. Cool. That's my eraser. Right, cool. At this point, is this looking like a bit of a pattern? Yeah, what does it look like? Hopefully that doesn't look like an asymptote, but that looks like a curve.
Looks
like
a non-linear.
Yeah, non-linear, yeah? So it looks like that maybe?
Yeah.
Cool, okay. On the other side, we run the exact same logic and eventually we'll come to the same conclusion. Great, okay. Does this graph do something interesting?
Yes. It doesn't touch the y and x.
Right, it's not touching those y and x axes. Well, we know that it doesn't touch this one, right? How do we know if it touches that one or not? Because it looks like it's getting closer.
Oh, because the numbers usually keep getting smaller.
Back 0.
Right, okay, so what we need to think about is, oh, okay, well, if it ever did cross this over, that would mean that the y coordinate would be 0. Okay, 0 equals 1 divided by something. If I try and apply algebra to that, alright, I'll just times by x. Alright, great. Oh dear. Alright, so what's that trying to tell me?
There's no answer.
Right, there is no real solution to this. There's no solution now. So, now we have to come up with a new way of describing this sort of behaviour. It's getting closer and closer and closer, but never touching. Okay, so what we do is we do a series of dotted lines, or dashed lines, dots or dashes. Don't do a solid line, just dots and dashes. Usually just above or just below, because technically it's right on the axis, but it's hard to draw dashes through a solid line because you'll never see the dashes. Cool. This line, if it goes exactly along the x-axis, what's the rule for that line?
What? So, X equals,
Uh,
Y equals.
y equals 0, there we go. So that's y equals 0, going that way. Cool, alright. This thing gets closer and closer up that way, closer and closer down this way. So,
X equals 0.
alright, also got another one of these things. And x equals 0. Cool. Well, it would be nice if we had a word to describe this sort of behaviour. And I have to spell check this because I never get it right because I only write the first 3 letters of it.
No, it's
Oh wow, I spelled it right. There you go. I won't. As soon as I transfer it, I won't.
It's the short one.
Yep, good.
T-O-T-E? P-A-T-O-T-E?
So, these are called asymptotes, or asymptotic behaviour. Usually what I'll do, I'll write ASY just above these to indicate that I'm talking about the asymptote and something else. Strictly speaking, you don't have to do that, you just have to have your dotted lines and whatever the rule is, I just add the ASY in there, just so it's clear what I'm talking about. If only if it's clear to myself. Go! Beautiful. 1 down. Alright, let's have a go at the next one. That's a 1. We'll move that 1. 1 over x squared. Okay, do we know what that looks like off by heart? Not yet, we haven't done it. Okay, what are you going to do? Right, just throw numbers at it. Yeah? What do you want to throw at it?
1.
1 over 1 squared. 1. Yeah.
1.
Gotta love those easy numbers. What do you want to throw at it next?
2.
1 over 2 squared.
1 over 4.
1 over 4, so a quarter. Out there. Great, what do you want to throw at it next?
Negative 1.
Negative 1, 1 over negative 1 squared.
Negative 1.
Oh, try again.
1.
Positive 1, yeah?
Positive 1.
Yeah?
Yeah.
Cool. What else do you want to throw at it?
Negative 2.
Negative 2, okay. 1 over negative 2 squared.
Oh, it'll be just on both sides.
Alright, okay. So this is going there. Right, if I throw a negative in this, how is it different to throwing the same version of the positive in there? So as in, if I threw in 12 or negative 12, is it going to make any difference?
It's going to reflect.
Right. What was the name for that sort of behaviour from last time?
Odd. No, even thing.
Right, it's an even function. Right? If I throw a negative value in this or a positive value in this, it'll give me the same end result.
Even
Cool, so
function.
this thing's even. So if it's even, what does the graph look like?
On top, positive.
Say again?
Symmetrical.
Right, it's symmetric.
Okay.
Yeah. Okay. So, well, I've only got 2 points. Probably be a good idea if I got some more. What other number could I throw in?
3.
I could throw in 3. All right, 3 is going to be way off here somewhere. 1 over 3 squared. 1 over 9, so it's way down there somewhere. Okay. What else could I throw in? Half, right? 1 over a half squared. What's a half squared? Quarter. What's 1 over a quarter? 4. So the half goes all the way up here somewhere. Well, that got carried away really fast. Right. So it escalated quickly. So this thing goes nuts pretty fast. But is this reminiscent of something else? Right, it's really similar to 1 over x. Right, it's just this thing, it goes a bit quicker, it goes down a bit quicker, and it's all on the top side. But there's a lot in common there, which is unsurprising because 1 over x squared, you'd probably expect there to be a fair bit in common. Great. Okay, our graph is not yet complete. What have we not labelled? Right, asymptotes. Cool. Where are the asymptotes?
Y equals 0 and x equals 0.
Right, the same two. How do you know?
Because it'll never touch the y or its x
Cool.
intercept.
How do you know?
Because if you sub in 0 into either one of those equations, it will be undefined.
Okay, so 1 over 0 squared. Well, that's 1 over 0, undefined. So I definitely can't have x equaling 0. So I've got a problem straight down there. Asymptote x equals 0. Cool. And if I try to make y equals 0, 0 equals 1 over something squared. well then I times by x squared and I get 0 equals 1. Well, that's a problem, so that must not work either.
Wait, we have to do line dash?
Do you have to do
Lines and dots?
lines?
Is it lines and dots or lines and dashes?
Either other. So you can do dot, 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 you can do dash, 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 dash. Just don't do one continuous line. Right, because if you do the continuous line is supposed to be the graph, right, which is in blue. A dot or dash line is supposed to be something that the graph is approaching or generally doing.
So, how many dots should we put on there?
As many as need be. It's just so long as it's clear that it's not part of the actual graph, that it's just illustrating something that the graph is or isn't doing. That's all it needs to do. Alright. Next guy. Root of x. Alright. Do we know what it looks like?
Yes.
You, TJ reckons yes?
Yo.
What does it look like?
Diagonals.
Okay. We'll find out. Okay. Everybody else is definitely not sure what this looks like. Cool. What are you going to do? Right, throw numbers at it, see what it does. What would you like to throw at it?
1.
Okay, 1. Alright, I throw 1 in, what do I get back out?
1.
1 goes to 1. Cool. Okay, what's the next number you want to throw at it?
4.
4, okay. Why 4?
Because it's a square number.
Right, it's a nice square number, so you're thinking ahead about what will go into it. Should I throw 2 into it?
You can.
You could, what's going to happen?
You get square root.
Yeah, root 2, what's that?
Yeah.
Not a fun number, right? Anyone remember roughly what it is? As a decimal?
1.3.
No, 1 point.
4.
No, 1.7 is cubed. Oh, sorry, 3.
Yeah, right, right.
1 point.
Someone said it over here.
1.3.
Yeah, no.
No, 1.2. 1.4, James. Oh.
1.4, roughly. So it's got a nice little pattern in the first bit, up the text garbage. So yeah. Let's put that up, cool. So we could do 2 to 1.4, but that's kind of hard to judge, so we'll avoid that. We'll go to an easy one, which would have been start with 4, square root of 4 is 2. So we've got up there. Great, okay. What else could we put in? Neg 1, alright, what's the square root of negative 1? Right, I if you do special, otherwise if you're just in methods, it's not a real number, we can't draw that. Cool, okay, what else can you try at it? 0, square root of 0. 0.
It touches the line.
Brilliant. Cool, okay. What's the next number that you would throw at this if we had space? 9, right? Which would only go up to 3. Cool, so as I go further and further this way, I have to go even further just to get one more high, right? So this thing's it's still going to go up, but it's going to go up slower and slower and slower and slower, and that's too steep. There we go, that's a bit better. Cool. Alright, I can throw in 0. Can I throw in any negative number into this?
No.
No. So this graph has an interesting feature then. It has what's called an end point, or a sharp point, depending on how you want to talk about it. So we'll label that 0, 0, my end point, and then this just goes off to infinity. Technically I should have arrows on this, but it doesn't matter that much. It's kind of implied. So these always go off. But yeah, generally don't bother drawing them at this stage. Cool. Great. We just learned 3 different graph types. Cool. Take a guess at what they're called.
S and
Hyperbola, one's called
Right, one's called Hyperbola, one's called Truncus, one's called Bruce. Guess which one's which?
Truncus is the top one?
No, they're in order. I put them in order for you. Right. Hyperbola, Truncus, Bruce.
Oh, Jake. I thought Truncus was. I didn't know what hyperbola was.
Yeah, that's fine. I'm not expecting you to, that's why I'm telling you what it is now. Cool. Hypers are one way of remembering what everything is. Like if you can't remember a root graph for roots, I mean, I really can't help you there because it's the same name. Truncus is easy enough to remember because it looks kind of like a tree trunk. Hypers, they're hyper. They go off to positive infinity, negative infinity, negative infinity. They want to be everywhere at once. That's their hyper.
Is that a way of remembering it or like they're all that?
Is that a way of remembering it or a way?
A little bit of both. Is it a way of remembering the name or is it why it's called that?
A little bit of both.
So belongs to the
What's that?
Truncus.
Okay.
So it's
Cool. Well, those graphs are nice and simple. There's no complications with extra numbers in there anyway. So let's complicate things a little bit.
Are we going to add numbers?
First things first. What are you expecting this to look like?
Hyperbola.
A hyperbola, right? This guy. Why?
because it's
not
set up the
square,
same way.
it's not root.
Right, I've got a 1 over an x. Right, so that fits this sort of form. Great. Okay, so it's probably going to look something like that. Great.
It's going to be right 2 and up 3.
Okay, you already got top of it. That's good.
Yeah.
Alright, so actually, if I say, oh, how many people reckon they already know exactly where this is going to go?
Yeah, I think so.
Yeah.
Oh wait, does
No.
do
Okay.
we have to state the curving point?
The curving point?
Like, because like H
You
and
mean
K,
turning point?
yeah, the turning point.
Okay. Does this graph have a turning point? No, it never turns over, right? This is always going up, and here it's always going up, so it never actually comes back down. So there's no turning point.
Oh, okay.
Label. Yeah. Cool. Yep. Good. Yeah, if it had a turning point, yeah, you'd label it. But in this case, it doesn't have one. Okay, all right. So for those of us that already know what it's going to look like, good. Hold up for a second. For those of us that aren't so sure what it looks like, we don't know what a graph looks like. What should we do?
Throw numbers at it?
So
Right. Throw some numbers at it. What might be a good number?
1,
1. All right. 1 over 1 minus 2.
negative 1, 1 over
Negative 1 plus 3.
is 2.
2. Okay. So 1 went to 2, which we'll put about there. Cool. So that's 1, 2. I'll rub these out when they get a bit clustered. But anyway. Cool. What else do you want to put in?
0.
Put in 0. Okay. 1 over negative 2.
Negative a half.
Negative half plus 3.
And 2.5.
2.5. All right. Well, there's 2. So about there is 2.5. So that's 0. 2.5. So 5 on 2. Great. What else do you want to put on there?
Not 2.
Not 2. Why not?
It'll make it 0.
Okay. But doesn't that tell us something?
Negative 1.
Right. It tells us where the asymptote
I
is.
see.
All right. I should say. So at 2, which is about there, we should have an asymptote. Beautiful. Cool. So this is x equals 2. That's my asymptote. Great. Well, that's handy. Hang on. Do I start that? 2, 2. This should be going. Did I do that the wrong way? 1 minus 1 is 2. Yes. 0 is a half. Minus a half is 5 on 2. Yeah, that's right. Oh, because, yeah, never mind. I'm going to move these preemptively now. Cool. All right, great. So we're on a roll. What do you want to do next?
Sub and negative 2.
Okay. Something negative 2, okay? Are you, okay, we'll do it. So something negative 2, we've got 1 over minus 2 minus 2.
Negative 4.
Negative 4, 1 over negative 4, negative a quarter.
Sorry.
Negative a quarter plus 3,
2, no, 2 and 3 quarters.
2 and 3 quarters, right? Is this getting a bit painful to graph?
Yeah.
Yes, okay, so throwing in some better guesses might be a good idea at this point.
Okay.
What else could we chuck in?
Negative 1.
Okay, you could put in negative 1, what are you going to end up with?
Like 2 and 2/3.
Right, you're ending up with these ugly fractions, yeah?
I'll put higher.
What might be a better one? 3, why is 3 better?
There's no 1 over 1.
Right, you end up with 1 over 1. That's nice and easy to work with. Cool, alright. So put in 3, get 1 over 1, that's 1, plus 3, 4. So we put in 3, and we got 4, where's 4? 2, about there, 3, 4-ish. Beautiful. Okay, what other number do we want to chuck in there? 4 maybe, okay. 4 minus 2, so 1 over 2, half, plus 3, 3.5. Alright, that's 5.5, so that's there, so that's about there. This becomes 4, 3.5. Oops, change that to 7 on 2. Cool, okay. Might there be a better way of thinking about this then? Because it looks like we're going to get a whole lot of ugly fractions. Alright, well, let's think about this. Because this asymptote, that was really good, because that gave us a very clear delineation of what's going on. We know that there must be one that goes that way as well, right? A horizontal asymptote. Okay, well,
Oh,
what value can I never reach with this equation?
3.
Say again?
3.
3. Why?
Because you're plussing 3.
Right, so I need something plus 3 to equal 3. Well, that means something has to equal 0, which means 1 divided by something has to equal 0, but that doesn't happen. So, we get asymptote y equals 3.
Which is H and K.
Right. Yeah.
I told you. You said H and K is your target.
No.
I mean, H and
Because
K
you
is
said turning point. That was
Special.
the problem that you're having. Alright. What you meant and what you said, two different things. Beautiful. Great. Well, we're already pretty sure that it's going to look something like this. Great. So it must look something like. Move that bracket out of the way. Something like. Ooh, that should come back. There we go. It should get closer and closer and closer. Great. Move this a little bit. There we go. Cool. And this guy should get closer and closer and closer. Something like that. Beautiful. Okay. Cool. We've got a graph. Is there something noticeable missing off this graph?
Oh, the intercept line.
Right. Which intercept?
X and Y.
X and Y. Well, we didn't actually happen to stumble on that. Right? We threw a 0 in. So that's nice. But yeah, we need this x-intercept. How do we get x-intercepts?
Make one equal 0.
Right, make y equals 0. Great. Okay. 0 equals 1 over x minus 2 plus 3.
minus 2.
Cool. Minus 3. Now what?
Times X plus minus 2.
Right, times this whole denominator. So we've got minus 3 multiplied by all of this equals 1, and
Then divide by 3.
divide by 3,
And then plus 2.
divide by negative 3, and then add 2. Add 2 to that, what do you get?
Positive 5 on 3. Positive 5 on 3.
5 on 3, are we all okay with that? Yep. Beautiful. So we get 0.5 on 3, 0. Cool. Have we labelled everything? We've labelled x-intercepts, y-intercepts, and asymptotes. That's it. There's no turning points. We're good. Okay. Woo. Alright. Can we learn a general lesson from this?
Yes, yes you can.
Actually, sorry.
H and K with special abilities.
Alright. Let's go blue. Where is it? Green. Cool.
I just put your brackets around that x minus 2.
Right. So, I'll leave that over there. There you go. But there's definitely something going on there. Cool. We're looking at this guy now. What do we think is going to happen?
It's going to go left 2 and up 4.
Left 2 and up 4.
And
Right.
it's going to be it's going to be opposite side.
Oh, very good, DJ. Okay, so we're going to look at it and go, right, I know that this thing shifts it left and right. If it's minus 2 here, it ends up being positive. Okay, so plus 2 must mean it goes negative 2. Actually, we'll move that up there. X equals negative 2. Great. What was my other asymptote?
Huh?
Positive 4.
Positive 4, right? Because we know it shifts it up by 4. Great. Well, asymptote y equals 4. Great. Okay. Now what do I do?
Wait. Shouldn't you make space on the top left and the bottom right?
That's a good point, TJ. Maybe I stuffed up. How do we know where this thing goes?
Because it's negative 1 divided by. And
Okay, so what should we do so that we can figure out where this goes?
Throw numbers inside.
So you can throw in some points, but we know in advance that we're going to have to figure out the x and y intercepts, right? So why don't we just do that as our points? So what's the easier of the two?
2.
Is it
Like
is it easier to find x intercepts or y intercepts?
Y.
Y intercepts, right? Because you just throw in a 0 and off you go. Cool. All right. So y intercept is going to be -1 over 0 plus 2 squared plus 4. Cool, okay.
2 times 2 is 4. 4 plus 4 is 8. -1 over 8.
Too fast for yourself there, TJ. Try again. 0 plus 2, 2. 2 squared, 4. Then you're dividing. -1 over 4.
Oh, and then you plus by 4.
Right, so we've got -1/4 plus 4. Gives me?
15.
15 on 4. Okay, that's my y-intercept. 15 on 4, bigger or smaller than 4? Smaller, so it must be slightly underneath.
Wait, what are you?
Cool.
I thought it was 16 over 4.
Great. What else do I need to figure out? X-intercepts. How do I do that?
Just sub 0.
X, y, 0. Alright. 0 equals -1 over x plus 2 squared plus 4. Great.
-4.
Minus the 4 over.
-4 times x plus 2.
-4 equals -1 over x plus 2 squared. What are you going to do from there?
Negative by x plus 2 squared.
Okay, might I say something? You've got a negative and a negative.
Oh,
Right, cancel them straight away. Get rid of a negative. Negatives always cause you trouble, so get rid of them when you can. Cool, alright, times across, great. 4, lots of x plus 2 squared equal 1.
Minus 4. I'm divided by 4.
Hopefully.
And then plus 2.
What happens is
Oh, we square
I need to square root it.
Plus or minus the square.
Ah, very good, TJ. Plus or minus. And then -2 plus or minus the square root of 4. What's the square root of 4? Half.
I don't get that.
You didn't get that, or?
No, I do now.
Oh, you did get it. Okay, good. Cool, alright. A half plus, sorry, -2 plus a half. -1.5 in fraction. -3 on 2. -2 minus a half. 5 on 2. Brilliant. Okay, -3 on 2. Can I label that answer there? Yes. -3 on 2, is that to the left or right of -2?
To the left.
To the right.
To the right, mate.
To the right.
-3 on 2 is -1.5.
Oh, I'm talking about the other one.
You're talking about the other one, that's convenient. Okay. Okay, so this guy is, what did we say it was? -3 on 2. And this guy is -5 on 2. Cool.
Oh, and it was always going to be like that because it was an even function. And since it's gone negative, it'll be on the bottom.
Okay. How are we going to connect up the dots?
Because looking from the even function, it's you sub.
Oh, that was a bit bad. That's still pretty bad. But
This is a Truncus.
Yep.
Which means the other one is just going to go one way. It's not going to go
Okay,
through
so we
that.
get that. Cool. Alright, so we had the 2 moved it across, the 4 moved it up. What did this guy do?
It flipped it.
Right, flip the whole thing. That guy's going to do us a flip. Okay. Plus 1. Maybe I should put an extra number on. Yeah, it's alright. Cool, alright, I've got this boy. Alright, any guesses on what's going to happen?
It's only going to go one way.
Does it have an ending point?
Like it's only going to go. It's either going to go. It's not going to cross to the other side.
It's not going to cross to the other side.
It's not going to cross the x. It's simply y.
Okay, so we've got some thoughts, right? Is everyone happy that it's definitely going to go down by 1? Yeah, and it's just this thing that's throwing us out now?
It's going to be a regret.
Alright, is anyone 100% sure what it's going to look like?
Yes.
TJ is overconfident as always. Pretty good. Riley reckons? Okay, we'll find out. Okay, for everybody else, what are we going to do?
Find the y and x intercept.
Right, find some points on it that we know are on it.
-1.
By doing, and saving ourselves some work, we'll figure out y and x intercepts. It is root -0 plus 1 minus 4. Great. What do you get?
-3.
Thanks, right. Beautiful. Woo indeed. Cool, okay. Great, what are we going to do from there?
Work out the
X-intercept, how do we get that?
+4.
Y.
Make y 0. Cool.
Plus 4 square would be 2, and then minus 1, which is 1, and then divide by negative, which means it'll be x equals negative 1.
Okay. Cool. Alright, so that's way over here somewhere. Yep. Great, okay. Well, how do these things connect? How many ways could I possibly connect those? Quite a few.
Shouldn't that be negative 15, 0? No.
Negative 15, so, oh, whoops, sorry, thank you. This is the problem when I'm talking, right? Okay. Cool, negative 15, 0, thank you. Cool, okay, so, well, I could even draw a straight line through that potentially, so that's not very limiting. Alright, what's the special feature from this?
Negative 1 and bottom minus 4.
Endpoint. Sharp wood, if you want to call it that. Alright. Well, how can I make this thing do that? Well, that just happens when the square root part equals 0. What value of x do I need to make this thing equal 0?
1.
1. Right? If I put in 1, what do I get? I should have put this on the other side.
You get negative 4.
Cool. 1, negative 4, somewhere around here. Actually, more like that. 1, negative 4. How can I be sure that I've found the endpoint?
Sub it in real quick.
Subbing something slightly above and slightly below it. If I put 0.999 into that, will I get a result? Yeah, it'll be tiny, but I'll get a result. If I put in 1.001, will I get a result?
No.
No, because I'll end up doing negative 0.001, which I can't take the square root of. So I know immediately, yeah, that had to have been right. Alternately, you can just make this thing equal 0 and then know straight away. But if you're ever unsure, just test it with things like that. Cool, great.